Let's go over the Unit 6 test review for Algebra 2. There are 10 problems in total. For problems 1, 2, and 3, you'll be given a function, and you have to find the first reference point, the second reference point, and the horizontal asymptote for that exponential function. For numbers 4 and 5, you'll be given a graph, one for exponential growth, another for exponential decay, and based on the information in the graph, you have to tell me what the exponential function in standard form is for that graph. Finally, for 6, 7, 8, 9, and 10, we've got some word problems. You have to find what the exponential function is that fits that situation. So let's go back to the top and start with number 1. Here we're given the parent function is f of x equals 2 to the x, and the transformed function is g of x equals 2 to the x plus 4, and then minus 7 at the end. Find the first reference point, the second reference point, and the horizontal asymptote. All right, so before I do any of that, I have to find what a, b, h, and k are. So over to the side, I'll start with a equals, b equals, h equals, and k equals. Now from the standard form, I'm going to start at the very back. K is the number at the very end. So this is going to be minus 7. So k is negative 7. H is what is being subtracted from x. So up here I see x plus 4. So h is not 4, h is negative 4, because h minus negative 4 would be the same as x plus 4. So h equals negative 4. B is the base to my exponent. So this is 2. 2 to the power of x plus 4. So b is 2. And then a is a multiplier at the very front. This tells me my vertical stretch or compression. Here, I don't have one. So if I don't have a number at the very front saying, 3 times 2 to the x plus 4, 5 times 2 to the x plus 4, then a is 1. Worth noting, if a is not there, it is 1. But if h or k are not there, notice h is what's, again, being subtracted from x, and k is what is added or subtracted at the very end. If neither of those are there, or each of them aren't there, they are 0, because they're being added or subtracted, versus a is being multiplied. All right, now that I have these, I can go ahead and find what reference point 1, reference point 2, and the horizontal asymptote are. For the first reference point, so let's put down reference point 1. This is h, comma, a plus k. So that'll be h is negative 4, comma, a plus k is 1 plus negative 7. So this is negative 4, comma, negative 6. All right, reference point 2. What you use for reference point 2 will be based on whether the function is exponential growth or exponential decay. Take a look at b. If the absolute value of b is greater than 1, then this is growth. If, however, this is between 0 and 1, so if it's less than 1, then this is going to be decay. Here I see growth, b equals 2. So that tells me that for reference point 2, this is h plus 1, and then comma, a times b plus k. All right, so what do we have here? H plus 1 is negative 4 plus 1. And I say comma, A times B is 1 times 2, and then plus negative 7. Negative 4 plus 1 is negative 3. And then 1 times 2 is 2. Add negative 7, so that'll be negative 5. So reference point 2 is negative 3, negative 5. And lastly, the horizontal asymptote. This is always y equals k. So I have a horizontal asymptote at y equals k is negative 7. All right, let's go to the second one. For the second one, this is 5 to the x and then plus 4 at the end. Again, I'm going to start out by finding a, b, h, and k. I always start at the very end. K is the number that's being added or subtracted at the end. So I've got 4. K is 4. Here, as mentioned, h is what is subtracted from x. I'm not subtracting anything from x, therefore, h is 0. B is the base. So the base to this exponent is 5. 5 to the x. And a is what's multiplied at the front. I don't have anything there, so a is 1. Okay, for the first reference point, this will be h, comma, a plus k. So what do I have here? 0, and then a plus k is 1 plus 4. So this will give me 0 and 5. The first reference point is 0, 5. For the second reference point, again, I take a look at b, and this is greater than 1. So this is growth. I'll be using h plus 1, and then a times b plus k. So h plus 1 is 0 plus 1. And then a times b is 1 times 5 plus 4. So 1, then 1 times 5 is 5, plus 4 is 9. Reference point 2 is 1, 9. And lastly, the horizontal asymptote. I'll have a horizontal asymptote at y equals k. So this tells me my horizontal asymptote is at y equals 4. All right, now compare this to number 3. The first thing I see with number 3 is that my base is a fraction. It's 1/3. So this automatically tells me that I'm going to be working with decay instead of growth. Regardless, I'm still going to find a, b, h, and k first. So a, b, h, and k. Let's start at the very end again. K, I'm not adding or subtracting anything here. So k is 0. H, I'm not adding or subtracting anything to x either. So h is 0. b is the base, so this is 1/3. And a is the multiplier at the front. Here I've got 2 times 1/3 to the x, so a is 2. Okay, so my first reference point is still going to be the same, h comma a plus k. Zero, and then a plus k is 2 plus 0. So this is 0, 2. So how you find the first reference point does not change whether it's growth or decay, but how you find the second reference point does. For growth, 1 and 2, I used h plus 1 comma a times b plus k. For decay, however, instead of h plus 1, this will be h minus 1. And then instead of a times b plus k, this will be a divided by b plus k. So h minus 1, this will be 0 minus 1. And then a divided by b is 2 divided by 1/3. And then plus k at the end is 0. 0 minus 1 is negative 1. Now here I've got 2 divided by a fraction, 1/3. If ever you divide by a fraction, you can think of this as multiplying by the fraction's reciprocal. So the reciprocal of 1 over 3 is 3 over 1, or 3. So 2 divided by 1/3 is the same as 2 times 3. That'll be 6. So 6 plus 0 is still 6. And the horizontal asymptote will be the same still. We'll have a horizontal asymptote at y equals k. So the horizontal asymptote here is y equals 0. All right, let's move on to the graphing problems. Number 4. So I want to find the exponential function that fits this exponential growth graph. Let's take a note of a few things. I've got 2 points. The first point is 3, 2. The second point is 4, 5. And I've got a horizontal asymptote here at y equals negative 1. Okay, for growth, what's important to note is that your first reference point is always to the left of the second one. So my first reference point is 3, 2, and my second reference point is 4, 5. I'm actually going to write that down. So this is point 1 right here, and this is point 2. And then I'm going to begin with my horizontal asymptote. The goal here is to write this function in standard form. I will need to find what a, b, h, and k are in order to do that. So I start with what I think is kind of the easiest thing, the horizontal asymptote. I've got a horizontal asymptote at y equals k. That's kind of the formula for it. Well, what is the horizontal asymptote here? It's at y equals negative 1. So this tells me that k must be negative 1. Okay, now I can go to my first reference point, which is 3, 2. I know from earlier, problems 1, 2, and 3, the first reference point is at h, comma, a plus k. Well, now I know that this first reference point is also the point 3, 2. Which tells me that h equals 3, left equals left. And it tells me that a plus k is 2. Well, I found k earlier. K is -1. So a plus -1 equals 2. And if I were to add 1 to both sides, I would find that a is 3. All right, moving on to the second reference point. Because this is growth, kind of the point for the second reference point here is going to be h plus 1, and then a times b plus k. Well, this point is actually at 4, 5. So I can say that this is 4, 5. Now, I don't care so much about the left parts here, because h plus 1 equals 4. This is only going to help me solve for h, which I already have here, h equals 3. But what I do care about is the right side. This is a times b plus k is equal to 5. And now that I know what a is, 3 times b plus, and I know what k is, -1, I can plug those in and solve for b. So let's add 1 to both sides here. I'll get 3b is equal to 6. And then when I divide by 3, b equals 6 divided by 3 is 2. Once you've found a, b, h, and k, you can go ahead and plug them in to your standard form. G of x equals 3 times b is 2 to the x minus h. So x minus 3. And then plus k at the end, so plus -1, or just say -1. But compare that to exponential decay, number 5. For exponential decay, I'm going to look at the same type of things. I'm going to look at my 2 reference points here, as well as what my horizontal asymptote is. However, with decay, my first reference point isn't to the left. My first reference point is to the right. So this is point 1, and then this one up here is point 2. I still begin with my horizontal asymptote, though. I see that my horizontal asymptote is at 2. So my horizontal asymptote is at y equals k. Here I see y equals 2. So this tells me k equals 2. Then I look at the first reference point. And regardless of growth or decay, your first reference point is h, comma, a plus k. I've identified my first reference point is -1, 4. So this tells me left is left, h equals -1. And right is right. A plus k is 4. Since k equals 2, I can say a plus 2 equals 4. And then subtracting 2 from both sides, a equals 2. Now my second reference point I have to be careful with. Because this is decay, this is no longer h plus 1, comma a times b plus k. This will be h minus 1, comma a divided by b, and then plus k. So this is actually at negative 2, 8. And again, I don't need to solve the left part of this, h minus 1 equals negative 2, because that's only going to help me solve for h again, and I've already got that over here. So I'm just going to do the right parts. A over b plus k. This is equal to 8. Let's plug in what we know. A is 2, so 2 over b plus 2 here. This is equal to 8. So if I subtract 2 from both sides, I'll get 2 over b is equal to 8 minus 2 is 6. I can write this as 6 over 1. And then if I cross multiply, up here I can get 6 times b is equal to 2. And then dividing both sides by 6, I get b is equal to 2 over 6, or 1/3. And now once I've found a, b, h, and k, I can go ahead and plug them in. So a is 2 times 1/3. This is to the power of x minus h. So x minus negative 1, or x plus 1. And then finally at the end, plus k, so plus 2. All right, halfway there. Second half goes by a little bit quicker. For the second half, this is problems 6, 7, 8, 9, and 10. I'm just trying to find a function given the information. So for number 6, I've got the population in a rural area is 48,000 and is growing at a rate of 3% each year. Okay, so this is exponential growth. It even says growing. Find the exponential growth function that models the population over time. For this, I'll be using g of x equals a times 1 plus r to the t, or you can say to the x. Here I'll need to know what a and r are. A is the initial amount, my starting amount, that's 48,000. So a is 48,000. And r is my rate. So r is 3%. So that's 3 over 100, which is 0.03. Taking a is 48,000 and r is 0.03, I can plug them into this and say g of x equals 48,000 parentheses 1 plus 0.03 to the x. Number 7. A computer is purchased for $1,300. The value decays at a rate of 18% each year. Okay, so this is exponential decay. Find the exponential decay function that models the value of the computer over time. For this, it's going to be very similar to number 6, except growth to decay. This will be g of x equals a is still going to be your starting amount, parentheses 1, but this time instead of plus, minus r, because we're decaying, to the x. I still only have to find these two things though. A is what we start with, so that'll be 1,300. And r is the rate, this time it's the rate of decay. So this is 18%. I say this is 18 over 100, which is the same as 0.18. And now plug them in to this. So I've got 1,300 parentheses 1 minus 0.18 to the x. Number 8. A person invests $3,300 in an account that earns 4.15% annual interest compounded once per year. Okay, so this is only once per year. If it's only once per year, it's going to be very similar to number 6. G of x equals A is my principal amount, what I'm starting with, times 1 plus r to the x. All right, A is 3,300. And R is the rate. So it's 4.15%. So 4.15 divided by 100, which is the same as 0.0415. Now I can go ahead and plug them in. G of x equals 3,300 parentheses 1 plus r, so this is 1 plus 0.0415 to the x. Number 9, however, a person invests $1,750 in an account that earns 5.35% annual interest, this time compounded quarterly. So when it's compounded more than once per year, I use this function, g of x equals a, and then instead of 1 plus r, this will be 1 plus r over n. And then this is to the, instead of x, n times x. So I still need what a and r are. In this case, a is 1,750, and r is the rate, so that's 5.35%, so 5.35 divided by 100 is the same as 0.0535. But I also need n. N is how many times per year the interest is compounded. So n equals quarterly. There are 4 quarters in a year. If this says semi-annually, then n would be 2. If this said monthly, then n would be 12. If this said daily, n would be 365. So be careful with that. Make sure you're using the right number for n. So let's plug all this in. G of x equals 1,750 times 1 plus my rate over the number of times I'm compounding. So that's 0.0535 over 4 to the 4x. Lastly, number 10. A person invests $4,600 in an account that earns 3.25% annual interest compounded continuously. As soon as I see that word continuously, this tells me I'm using something really different from all the other ones that we've used. This is going to be g of x equals p times e to the r. And then normally I would say t, but in this case, x. It says g of x, not g of t. So p is similar to a. This is my principal amount, what I'm starting with. E is a transcendental number, so I don't have to do anything with that. When I put that in my calculator, it will recognize what that is. It's similar to pi. Pi is another transcendental number. R is still my rate. So really, I just have to find what P and R are. It's similar to finding what A and R are, but I just have to plug them in differently. So P is 4,600 And R is 3.25%. So 3.25 out of 100. This is 0.0325. When I go to plug them in, this will be g of x equals 4,600 e to the 0.0325 x. All right, your test is going to look very similar to this review. Hopefully this helps you out. Please study, and if you have questions, let me know.